And so this is the circulatory system lecture. As with many of these, I feel like I don't give the full anatomy and physiology the justice that they deserve. However, I think that it still provides just enough information to understand some of the age changes that can take place. So we're starting here, big Roman numeral 1, basic heart anatomy. And many of you would be able to teach this part, and that's great. But I just want to review it for everybody that there's 4 chambers of the heart. The 2 top chambers are the atria, so there's a right and a left atria. And then the 2 bottom chambers are the ventricles, so there's a right and a left ventricle. So it looks something like this. And now you can see if you draw a heart here, you can actually get a heart out of that. Indeed, the bottom of the heart is actually a point down there. It's called the apex. Well, blood flows through the heart in a specific order. I'll do this in a different color here. So it starts at the venae cavae. There's one that comes from above the heart. There's one that comes from below. And these come into the right atrium. The blood then moves into the right ventricle where it's pumped out. It didn't go through anything else. It just got pumped out to the lungs, into the pulmonary circulation. Or of course, it drops off carbon dioxide, picks up oxygen, and then it returns back to the left atrium and to the left ventricle. And from the left ventricle, it gets pumped out to the body. So it says the aorta, which actually comes up posterior to behind the heart, but hard to draw here. And then out to the systemic circulation where it feeds the tissues with the oxygen and nutrients, picks up the carbon dioxide, and then will eventually come back. So it's this circuit that is going through, and it's called the systemic circuit. That's the part out here in the body. In the lungs, it's called the pulmonary circuit. All right, there are valves that ensure the one-way flow of blood. Because when the heart contracts, what keeps the blood from pushing backwards? Well, it contracts, a valve closes and closes that direction off, and so the blood can only be pumped out one direction. But what happens if you have a slightly leaky valve? Well, depends on how leaky it is. There's something called mitral valve prolapse, more common in women, and in many of them it's just benign. It doesn't really cause any problems. In some individuals, if it's a little bit worse, maybe it makes you a little more tired if you up your activity levels. Or in other individuals, you have so much blood leaking backwards that it causes all kinds of problems because the heart has to work too hard. But you have to go, of course, to a cardiologist and have that looked at and find out, what are the real effects and how dangerous is it. The heart wall has 3 layers. The innermost layer is the endocardium, lines the inside of the heart. The myocardium is the cardiac muscle, and that's found in the middle layer. And then the pericardium is the outer wall of the heart. Coronary arteries supply blood to the myocardium, and therefore they are important. We don't want blockages in these because the heart muscle has to contract 24/7, 365. Well, if you train regularly, aerobic style training, endurance training, the size of these coronary arteries will get bigger. They will also increase in density, meaning you have more of them supplying the heart muscle, which means that now even if you get a blockage in one, then it might be able to get around and get to because you've developed these additional pathways, if you will, it might actually lead, you might be able to get the blood around it anyway. And so that's one of the benefits of exercise. But if you do get a blockage in one of these coronary arteries, it can lead to myocardial infarction, where there's a part of the heart that is not getting the oxygenation and tissue that it's needed and is quite sensitive to that. So that's the heart. The other part of the circulatory system is blood vessels, which we will categorize as arteries, veins, and capillaries. This is really simply defined. Arteries carry blood away from the heart. Veins carry blood back to the heart. Okay? Well, these veins, because many of them are coming up your legs and so forth, and there's not a lot of pressure to help push that blood up, there are valves. They're one-way valves. So as the blood moves up, it can't go back down. And then it'll move up a little more and can't come back down. If these valves fail, then the blood can pool in that part of the vein, and that can actually lead to varicose veins. And varicose veins might be benign, it might just be a cosmetic issue, but it can also actually indicate there could be some blood flow issues, and when blood flow is not fast enough, that blood can clot, which is going to cause problems because that clot can break free and actually go somewhere else in the body and get lodged and cause problems. Capillaries are found between arteries and veins, and even when I say arteries, they actually start really big and get really small, and then the veins, after the blood goes to the capillaries, start really small and get really big on the way back to the heart. Well, the important function of the capillaries is that they exchange gas, the nutrients, the waste, and we do lose a tiny amount of fluid at the capillaries that does not make it back in, which is why we have lymph vessels. This is the third part of the circulation that we get to talk about. The fluid that gets out of the capillaries into the tissues, if it kept getting out, you would have edema and swelling. But the lymph capillaries collect this, and then the lymphatic circulation actually will return it eventually back to the blood. But on the way, it goes through lymph nodes, which kind of monitor, hey, what's in this fluid anyway? And it gets filtered to the lymph nodes, they get exposed, find out if there's any pathogens there that need to be handled and taken care of. And then if they find something, then the lymph nodes, that's where the T cells and B cells are primarily located. They can actually begin to mount an immune type of response. Of course, the common disorder with lymph nodes that would affect us more with aging, although this can actually happen at early ages as well, is a lymphoma, which is a particular type of cancer. In fact, there's even two major types of lymphoma. And this is when the lymphatic cells have the cancer. They're called lymphocytes, and the lymphocytes are the T cells and the B cells. And this is actually the most common blood cancer and the one that my father passed away from. So the rest of what we're going to do here, a lot of it is just simply terminology, so that when you hear these things, you kind of understand what's going on. The cardiac cycle, because the heart goes through this cycle, right? We know the blood flows through in a cycle. The heart's going to have to contract in a cycle. The basic steps are the ventricles fill, so that's ventricular filling. Then the atria contract, and remember the atria, the blood is in there before the ventricles. So when the atria contract, that actually pushes more blood into the ventricles, fills them up even more, and functionally that actually has importance. Then the ventricles contract and push the blood out, and then the ventricles relax. It's really that simple. Now, students who have taken physiology know that there's a lot more to understand about what is happening at each step, but the steps are simple and actually fairly easy to follow. So there's a diastolic stage where diastole is really when the ventricles are relaxing, and systole is when the ventricles are contracting and pushing the blood out. So if you think in terms of blood pressure, when the heart is relaxed, blood pressure will be lower, so that's diastolic blood pressure. But when the heart contracts and pushes that blood out, it raises the pressure, and so that's systolic blood pressure. And so your cycle is also coordinated with those blood pressures, where it goes high, low, high, low, high, low. Both sides of the heart work together. So it isn't left beats, right beats, left beats, right beats. No, it's actually the atria contract together. Remember, we just saw that in the steps. Atrial contraction, left and right sides contract together. And then the two ventricles, left and right, contract together. So both sides are working in unison. And if you really think about it, if you're going to have a circuit where you're running a fluid through, you don't want to push part and then push part and then push part. You want it to work together at the same time to make that happen. Cardiac output is how much blood your heart is pushing through in 1 minute. Well, a simple way to calculate that is heart rate, how many times the heart beats in a minute, and stroke volume, which is how much is pumped out with each beat. So if we know how many times it beats in a minute and we know how much is pumped out with each beat, we can multiply those two and get the cardiac output. So heart rate times stroke volume is cardiac output. Note that cardiac output needs to remain constant. In fact, it's pretty much well tied to metabolism. If you have a higher metabolic need, cardiac output needs to go up to supply that. Well, if cardiac output, particularly at rest, remains constant, it'll go up, of course, if you exercise. With age, maximum heart rate decreases. Well, that means you cannot exercise with the same capacity when you get older. But it also means that if you exercise and you have a stronger heart, meaning you can increase stroke volume, if cardiac output is going to remain constant and I now have a higher stroke volume, then I'm going to decrease heart rate. So when I multiply these two factors together, I still have the same cardiac output. And this is why regular aerobic exercise leads to a lower resting heart rate. It's because it increases stroke volume. And this is also true in older individuals. But you don't change maximum heart rate. It's still going to decrease as we age, which means that even for somebody who exercises regularly and has a strong heart, their exercise capacity is going to go down with age. I do not have a solid explanation for that. All right, the next term here is venous return. Venous return is just like cardiac output, except now it's the blood coming back to the heart instead of the blood leaving the heart. But again, because this is a circuit where you go from the heart around and back into the heart again, the amount returning back to the heart in a minute would need to equal the amount going out from the heart in a minute. Otherwise, it's going to back up somewhere. And so venous return needs to match cardiac output. Left ventricular ejection fraction, or LVEF. What percent of the blood is ejected by the left ventricle each time the heart contracts? We never have 100%. Even at intense exercise where the heart is contracting forcefully, it may hit 90%. And so the blood goes into the ventricle contracts, but some blood is actually left in the ventricle. It's called the end diastolic or end systolic volume. Well, at rest, this left ventricular ejection fraction is usually about 60%. And this is what they use many times to determine if somebody has decreased heart function and might need a heart transplant. It's this left ventricular ejection fraction that they look at as a variable. Well, LVEF goes down with age. More blood stays behind in the left ventricle. All right, next term here, mean arterial blood pressure. Yes, mean is an average, but you can't just add the diastolic pressure and the systolic pressure and divide by 2 to get the average blood pressure. And that's because you spend about twice as much time in diastole as you do systole. And so you don't just add them together. So systole is only responsible about 1/3 of it, and diastole is responsible for 2/3 of it. With age, systolic pressure goes up, and you're always taught that 140/90 for high blood pressure, but when you're older, they actually let you go up to 160. And that's because blood pressure naturally goes up with your age, especially with arterial sclerosis, which is our next term, arterial sclerosis, which we defined early in the class. Hardening of the arteries. Why? Because calcium is getting deposited. And when the calcium gets in there, the arteries are less flexible, and that creates higher pressure. Atherosclerosis we talked about as being a subtype of arterial sclerosis, and this is where the vessel wall, of course, was damaged, and the deposits can actually begin to block off blood flow. An aneurysm happens when there's a weakened area in the arterial wall, it bulges out, and it can actually rupture, or it could actually impede on a neighboring blood vessel or tissue. Atherosis can contribute to aneurysms, hypertension contribute to aneurysms, but usually you put these two together and it makes it even worse. And of course, if they happen in the brain, that can lead to a stroke. A thrombus, this is when a blood clot, but you don't need to have a blood clot. the blood vessel is not damaged. When a blood vessel is damaged, we have a natural clotting mechanism to stop it from bleeding all over. This is where a blood clot forms in an undamaged blood vessel, likely due to low blood flow. It's just going too slow. If that thrombus breaks free, it's then called an embolus, and that embolus can float on, and then as it's branching into smaller vessels, it can get stuck there and they get lodged. It can block the blood flow to that area. It can be quite dangerous. It can cause a stroke, it can cause a myocardial infarction, it can get stuck in the lungs, back up blood flow. So it can cause some different problems in that way. The last term that I've put on here, let me erase here so we can see what we're looking at. A CABG, or CABG, is a coronary artery bypass graft. In other words, open heart surgery where they run the bypass around the blockage. It's really kind of interesting. They've done it a number of ways, but they usually take a blood vessel from another part of the body, sew it on one side of the blockage, sew it on the other side of the blockage, and now the blockage doesn't block anymore. You have bypassed it. But in order to do this, they have to crack the chest open. They saw through the sternum, they put clamps on either side and open up the chest. And then they reroute the blood through a heart-lung machine, stop the heart from beating, and that's when they do all of this work. And so the recovery from this, even though the heart is now probably quite healthy, you've had your chest sawed open essentially, and the recovery is quite difficult. So it can be quite an ordeal for somebody who is older and would have to recover from that. The very last point here that I just make, blood thinners, and note that I put this in quotation marks because they really don't thin the blood. But blood thinners like aspirin is one that people are commonly told to take, especially if they've had heart problems, because it will inhibit blood clotting. So that even if the blood flow slows down, it can continue to flow and it stops that clotting process. Many individuals are also placed on these blood thinners after surgeries to help to prevent blood clots.